Hi everyone, so this is aggregate 6, which is the relative density and absorption for fine aggregate. So in this lab, we're looking at two pieces of information, the absorption of our fine aggregate and the density of the fine aggregate as well. So we need absorption because we need to find out how much water can get into our fine aggregate so that we can adjust our water content in our mix design accordingly. And we also need to find the density of the fine aggregate so that we can convert volumetric measurements into relative masses when doing our mix design. So we're going to start off by weighing 1200 grams of soaked fine aggregate. So the fine aggregate has already been soaked in water for 24 hours and we measured 1200 grams, but this is an initial amount. We will actually need less when we are conducting our experiment. So when we put our fine aggregate in the water and we take it out, we would have water in our fine aggregate, in the pores of our fine aggregate, as well as water surrounding the particles of the aggregate. So since we only are concerned with the water that enter the pores, we need to get rid of the water that's residing around the surface of our aggregate. And in order to do so, we are going to use a blow dryer. So now the purpose is to eliminate the water that's residing around the surface so that we can get a total mass of 1, the aggregate, and 2, the water in the pores. And then we're going to take that total mass, we're going to put it in the oven, and we're going to achieve an oven dried condition. And the differences between those two masses is going to be the water that evaporated, and then we can calculate our absorption of the fine aggregate. So we are going to blow dry our aggregate using a blow dryer. So I've been blow drying it for a bit now. So in order to check if the water around the surface evaporated or not, we're going to be using this mold. So we're going to fill this mold with our aggregate. And then we're gonna lightly tamp the surface 25 times. And then we're gonna release the mold. So as you can see, the aggregate retained the shape of the mold, which means that there is water particles holding the aggregate together, and therefore our aggregate is not in a state of saturated surface dry. So ideally we want the aggregate to slightly slump, and that's when we achieve our SSD condition. So we have to keep drying it a bit more until we get the aggregate to slightly slump, and then we're going to proceed from there. So I've been drying it a bit more, so let's see if our aggregate reached a state of saturated surface dry. So now I'm going to lightly tap the surface 25 times. And now we're gonna release the mold. So as you can see, the walls of the mold fell apart, which means that there's no water on the surface holding the aggregate together. And now we got the aggregate to be in a state of saturated surface dry. So now we can proceed with the next steps. So ideally right now, we wanna take 500 grams of this SSD, put it in the oven, and calculate the difference between the 500 grams and the oven dried, and that's how much water is in the pores, and we can calculate our absorption, but we also need to calculate our density. So we need to calculate our volume, and we're going to be using a picnometer first to calculate the volume, and then we're going to be putting the aggregate in the oven to calculate the moisture. So this is the picnometer that we're going to be using to measure the volume. So we're going to take a couple measurements, and then from these numbers we're going to calculate our volume. So first we need to measure the mass of the empty picnometer. And then we're gonna measure the mass of the picnometer and the water that's gonna fill the picnometer until the datum point. So we're gonna put water in the picnometer now. So now we fill the picnometer with water until the datum point, and we're going to take the mass of the entire picnometer plus the water. From those two numbers, we can calculate the water, the mass of the water that is required to fill the picnometer. And now we're going to add 500 grams of SSD aggregate in the empty picnometer. So now we're adding 500 grams of SSD aggregate in the empty picnometer. So now we added 500 grams of SSD in an empty picnometer. And now we're going to fill the picnometer with water until the datum point. So while we're filling the picnometer with water, you have to make sure to wash the sides of the picnometer to have all the aggregate below our datum point. So while we're filling it with water, there is some air bubbles trapped within the aggregate. So we have to shake the picnometer to remove all the air bubbles. And then we're going to fill the picnometer all the way until the datum point. So now we're just filling the picnometer with water until it reaches the datum point. So now we're going to take the mass of the whole thing, which consists of the aggregate, the water, and the picnometer. So using the numbers that we just recorded right now, we can calculate the volume of our aggregate. So first, we can calculate the volume of the water that's occupying the picnometer right now, because we have the total volume of the picnometer and the water and the SSD. And we know there is 500 grams of SSD aggregate. we know the mass of the empty pycnometer. So the difference between those numbers is going to be the water that's occupying the pycnometer right now. And we know the total mass of water needed to occupy the whole pycnometer till the datum point. And the difference between that total mass of water and the mass of water that's in the pycnometer right now is the volume of the aggregate that replaced the water. And this is the volume that we're going to be needing in our density calculation. So density is mass over volume. So we have the volume, and the mass is going to be the oven dried mass of the SSD aggregate. So we're going to empty the pycnometer right now in a bowl, put it in the oven, and then after that weigh the oven dried aggregate. So all the material is now transferred to the bowl. So we're going to go oven dry it and come back and weigh the mass of that. So now it's been 24 hours. So let's take the aggregate out of the oven now. So this is the oven dried mass of our aggregate, and we're going to be using this mass to calculate both absorption and our density.